Okay, so I'm going to talk about two things to some extent. I'm going to talk about a library I built. I'm talking contracts overall. We're in Clojure. We don't have static types. Norm and I can rant forever about how this is a bad thing, not a good thing, but here we are. And I'm happy here, so I'm not trying to shove types down anybody else's throat. But that said, I'd like to talk about validating what data we do throw around and doing so in the form of contracts. And this is not old school contract-oriented programming where you have a big old def contract somewhere and you sling it around and you extend it and you ensure your interface is provided and all this stuff. This is fairly lightweight, just assertions and predicates and preconditions sort of stuff that you can use in your own code and that I'm using in production. And I will try and show you guys some of all of that in the course of this talk. So that said, what are contracts? They're a restricted form of proof, right? We want to make software that works. We don't want our software to blow up at runtime. And we can provide some of that, right? Or at least we don't want to have software that goes wrong and doesn't tell us it went wrong, right? If we're in other languages, we might be able to use types, we might be able to use assertions, we might be able to use compiler lifting, all this other stuff. But in Clojure, we can use predicates, right? We can make runtime validations. So our arguments must satisfy some predicates. Woo, hello. Apparently my arrow keys do the slides. I can't actually go back and forth. So our arguments must satisfy some conditions, the state of the world must, the outputs must, side effects must, yada, yada, yada. And this is equivalent to what other languages such as Agda do with real contract systems and real proof systems. Agda will actually emit a whole bunch of preconditions, right? So Agda will actually say, when I compile this code, I don't know. Might be right, might be wrong. I'm going to assert every single property that could possibly be true, and I'm going to optimize out the assertions until I either can prove that a code path works or a code path doesn't. So let's try and get something similar to that working in Clojure, and that is way too freaking large. All right, so now you get an example of this, right? As of Clojure 1.2, which is eons ago, we have preconditions built into the def and macro. So if you have the pre key in your macro, in your def metadata, you can give a vector of statements that must be true in order for the function to not immediately blow up on invocation, right? So here we have a function f that says divide the input by 2 if we can do this without loss of information, right? So if we have a double, we don't want to divide by 2 because we might truncate. If we have an integer type, we don't want to divide necessarily, because unless we can put it into a ratio, again, we might lose information. So we can provide that by saying, we must have a number, dividing a vector by 2 makes no sense, dividing a map by 2 makes no sense, and so forth. It's got to be even, otherwise we can't divide without loss information, or it's got to be a ratio, in which case we have a pair of numbers and we can multiply 1 by 2, multiply the denominator by 2, and get our divide by 0 with no loss of information. Make sense? So this works for some things. So if we say f of 1, that's going to blow up on us, right? We're going to get an assertion failure, not even. If we divide by 2, it's going to work fine. If we have an even number, we're going to get 1 back, or we're going to get the ratio 2 over 2, which is algebraically equivalent. If we divide 5 over 2 by 2, we get 5 over 4, which works. Dividing the vector is going to give us an assertion failure on number, and dividing by the map is also going to fail. So seems sane so far. And we can do the same thing on post conditions, right? So also as of 1.2, you can say post and give it a vector of functions that use the same syntax as the anonymous function one argument that say this must be true at the end, right? So you have post conditions that check the rest of the world, your vars, your environment variables, the status of other process, whatever you want. But here I'm just going to validate that the output is in fact a number, right?
What does it return when they fail?
So when an assertion will not, a function with assertions in pre and post conditions will not return on an assertion failure, right? It will exception, right? So you'll get a stack trace and a Java exception. You can catch farther back up the stack, but it's not like Haskell or something where you get a failure type that says, I got this failure and I'm now returning a failure value, or Go does the same thing, right? You have a pair that's result, comma, error. So there's no error here, there's just a Java exception that gets thrown. I think it's Clojure lang assertion failure or something or other. If you just catch exception, it'll catch it. It will not catch if you just say assertion failure. I forget exactly what the class hierarchy is for Clojure's exception. So for Clojure's assertion failure. So this works, but note that it'll die sometimes, right? We're in Clojure, and we use nil a lot to signal silent error. So we have this when, right? So when X. And that means that if we throw in nil, or if we throw in something else falsy, this will silently return a nil, right? Because the when will fail, the if condition of the when will fail, and we'll do nothing and return nil, and then our post condition dies. So our function actually isn't in compliance with its own contract. And I think that in this case, I think this motivates the contracts in terms of both preconditions and post conditions. Because if you lift what you want to be true into your documentation and you assert it in your preconditions or post conditions, you can validate that it happens, right? You can throw test check or something at your function, run it over some huge domain of inputs, and make sure that what you think is going to happen actually does happen, and it'll explode and tell you if it doesn't, which is much more valuable because it gives you precise errors rather than somewhere down the line saying, I tried to call a vector as a function and that didn't work, when you were expecting to have a map or a set that would operate as a function. So, I'm not the only person saying this. You may have heard of David Nolan. You may have heard that he doesn't like types. He has a blog post that I highly recommend called Life with Dynamic Typing, in which he quotes Rich as saying everything is not awesome. And he gives this really cool example of wrapping protocols and multi-methods in normal defins. And in the defin, you provide a contract, right? You say this shall be true of the input to the multi-method and the outputs from the multi-method. And then you give an extension point, right? So this is a Clojure implementation of exactly the contract pattern that I totally said earlier we weren't going to do. Because here we see that we're going to have a number input and the result must be even for any type. So we can go off and implement whatever protocol we want and make sure that whenever it's called through the return even interface, we actually do get an even back and the inputs made sense for any possible implementation of the interface, right? He also gives this cool example where you actually validate a non-component, right? So here he does a whole bunch of JavaScript interop to say, if I have a valid OM component and these other properties hold, then go mash it with an OM cursor and set some properties and return a result. So I'm not going to try and make you read this because it's yucky implementation interop, but the concept holds. So a case in point of this, if I can open it, is in Grimoire. So you may or may not have used the documentation website I maintain, conj.io. But this is a pattern that I use all over the place in implementing Grimoire's data store. So I have a bunch of operations here, list groups. So I say this must return, this is the implementation of the list groups operation, and it must be a function from a configuration to a success value that's either going to be a success with a sequence of groups or a failure with a failure message, right? So I'm way off in Haskell error land here, but the concept holds. And farther down, I have a defin wrapper that in this case has no preconditions because my code is garbage. But in other implementations, I do in fact use this pattern. So I have a predicate, Clojure Grimoire things, that says, is this thing a valid group for whatever the group type is? And I'm going to explain exactly the sort of map validation looks like in a minute, both in terms of my hand implementation of it, and then in terms of Prismatic Schema Library that helps automate a bunch of this stuff. But the idea is that where'd it go? Oh, right, it's macro defined. So I have okay, I'm getting out of order here. My apologies. So going back to David Nolan's example, in Clojure script, this works better than it works in Clojure because the Google Clojure compiler is magic. And it can do some really cool interprocedural optimization and figure out that you can, if you only call a function here, you can lift all of its contracts into the functions that call it and then optimize them out, right? If you can prove that they will always be true. And that's exactly what the Agda compiler does and a bunch of other actual contract-oriented compilers. The Clojure JVM compiler is not this smart. In fact, it's pretty dumb. And the Java JVM JIT is also not that smart. So for David Nolan's examples, this works great because most of it gets thrown away. In your own code, this can prove to be slow, although I'm going to show you some tricks around that to work with Clojure 1.7. So schema, which I mentioned briefly, actually, let's do the hand examples first. Sorry, I made these slides earlier today. Okay, so schema is a library from Prismatic that helps you define structures, right? So this is not, here's my def type, I'm gonna have a macro that constructs this and all this other stuff. This is the shape of the data I want. I'm saying here that I must have a key B, I'm gonna have a map with the keys A and D, and the key of the index AB, right? Keyword A, keyword B, must be of type string, and the index AC must be of type int. And the s/str and s/int here are Prismatic schema functions that are provided for you that validate those data types. So the schema library is really just a whole bundle of predicates that say, is this object, whatever Java JVM object it is, an instance of what we in Clojure think of as some logical data type, right? So int will say, is it a big num, or is it a Java long, or is it Java int, whatever it may be. And string, similarly, just says, is it a Java string, or is it some derivative thereof, right? So this defines a type, quote unquote, really just a big validator function, right? And you can compose them. And that's exactly what this def is doing here, right? It's saying, here's this map that's only data. There's no function here. And it has a bunch of validations. So your str, your int, your keyword, your num. I'm sorry, this bracket notation is vector of, right? So this is saying every element of this vector must be of type snum for whatever value satisfies the snum constraint. And then we can validate against this, right? So we can take some map instance and we can say, does this type, quote unquote, our validator record, match to our input? So if you have a mismatch, if you have missing keys, if you have things of the wrong type, this can give you a validation exception early, right? So rather than trying to go way down into your implementation details and then use some piece of data, at the interface level, you can say, hey, you gave me the wrong thing. And you can provide much more precise errors this way. Tagged values. I originally intended to duplicate Janine's slides from Clojure Conj 14 here. I didn't have time to do that. She has a very good talk on using tagged values a la ML in Clojure using vectors and keywords. I highly recommend that you go check it out. I'm going to do some of it because Guttentag wraps it. So the thing I want to demo here, and this is a shameless plug, this is a tool I threw together on top of Janine's talk to try and make it more usable, is Guttentag. The name's a joke because it's tagged values and it's also German for good day. And the idea is that I want to be able to define a type logically. And I also want to get a bunch of stuff along with it, right? So Prismatic schema is pretty great and it lets me validate my data, but it doesn't give me any of the convenient stuff that, say, def record does, right? It doesn't give me constructor function that can actually provide building this thing or anything else. It also doesn't let me introspect a piece of data and tell me what it is, right? So in our previous example of the schema thing, right? We just have a piece of data and we have the logical type of the data disjoint from the actual instance, right? So we have our structure and then our object, and we validate the object against the structure. The structure doesn't tell us, so the object doesn't tell us what it is, right? And that's often something that we do. You may or may not have seen or written this pattern. So type, foo, data, whatever, right? And then you dispatch on the type keyword of your map. And the whole point of Janine's talk, which I'm forced to paraphrase here in order to motivate Guten Tag, is this is the anti-pattern, right? Because the type keyword can be missing. And even if you assert that the type keyword is always there, you still have all these issues with validating the entire structure of your map. If you really want to do this right, you have no choice but to go reach for core typed or another type checker-like tool that can provide guarantees statically. But you can do better than this in terms of dispatch, because you can do something like this. So foo and whatever data. And this works a little bit better because you can this solves the problem with schema, right? You have a name, you know what logically you're supposed to have. And it's something printable and something human readable. But it also lets you do pattern matching, right? And so you can go with core match and say, as Norman lectured us 2 months ago, I think, and then start matching on the fields of your thing and provide properties about the different fields. So if I have a keyword and an S string and an S number, I can actually go match using core match against exactly this record pattern. And if any of these is nil, I fall through and I immediately get an error, a match failure. Unlike a destructuring with a raw map or destructuring with a raw vector, where you will actually bind one of these to nil and now something else blows up and you get an imprecise exception again. So the whole idea of Guten Tag is, originally when I started messing with this pattern, I wound up doing this a whole bunch. So defen, my type, A, B, C, D, and then a whole bunch of preconditions. Hello, Control J, please work for me. F of A, G of B, and so on and so forth, right? So I would manually type all this out. And then I realized I also wanted a predicate, right? My type of X that checks the tag and then rechecks all the predicates to make sure that the structure is valid and I didn't just make it by hand rather than using the constructor. And so this is Lisp, and we can do cool things here. So I went and wrote a macro for all this, which is the core of the Untitled library. Whoa, that's the data reader's file. All right. And that's kind of the whole idea here, right? I have a macro that generates a smart constructor, to use the Haskell term for this, right? So it's a function from a bunch of data that runs all the assertions to make sure that you're not building something insane. And if all the assertions hold, it gives you back a datum, right? Or an assertion failures and you know you had something insane and you now have, again, a precise exception. And the reason this is cool is it's not just a vector, right? So if I have, let me actually go to REPL here. If I just have the vector, the tagged vector pattern that Janine's talk is about, you run into this problem where you have to manually maintain the tag, right? It's like metadata. You lose it instantly once you start modifying it, because you have to go index into your vector and pull out the thing you care about and modify that and then put it back. And it just doesn't update nicely, right? This is Clojure. We have updating, we have usosh, we have disosh. We want to be able to do these things elegantly. We don't want to be manually maintaining the parts of our data that are supposed to be implicit, right? Yes, I know my site is updated. Thank you for reminding me. Am I keeping you awake? So the whole idea here is I can say something foo of x, and we're going to say and that's all it takes, right? So I now have a function foo, so foo of 3, right? And this gives me back a record type. So this actually went and generated a constructor. I have a type. That's the Guten tag record thing. This is a pair, right? And it's a pair of keyword and of a map. And then you can see here that the keyword got namespaced implicitly with the namespace for what was defined and the name of the type it's supposed to have. And then as of the record, I have a bunch of mapping, in this case only one mapping, but I have a mapping from names to values, right? So I can say x of *1, and we get 3 out, just as if this is a normal map, right? And I can say assoc *2, so this is now *1 and that's *2, foo 3, right? So now I'm gonna put extra data into this thing that's not supposed to be there. And that works. I can put put a foo into my 2 value, right? And this works just like a normal map. I can desock it back out, right? And you can just mash on it, same as you would any other map. And this turns out too great because it unifies the tag data pattern, and you can check the tag. We actually seek this *1, right? This turns out to be a sequence of the tag and the value according to the seek operation, which means that core match can match on this as a sequence, and you can destructure the sequence and all this other cool stuff. But the value here is that the tag is maintained implicitly, right? In all the associating and dissociating we did here, and as much as you care to do, the tag is maintained. It can always be validated. You can't lose it, right?
It's not validating each time you associate to it?
It's not right now. That's something I've gone back and forth on being a good idea or not. And I have yet to figure out a good way to expose that as an option in the macro.
So what is it? So right now it's just whenever you call that first foo3, it's going to validate?
Sorry?
The only time it's going to do anything is when you call it the constructor, I guess?
As of right now, yes.
Okay.
Or you have to type check. Is that question?
Sorry?
But you have question mark foo?
Yes, so there's a predicate here as well. So foo of *1 is actually why is that invalid? Foo of
Because it's in
1.
your seek?
Because it's a seek without the tag.
Oh, good point, thank you. So let's go back here and make my foo again. And now foo of 1 is totally valid, right? And right now the foo predicate, this is all stuff I need to mess with. So right now the foo predicate is lazy, right? So it'll only validate the properties you said you cared about up above. So if we actually go and associate some stuff back into this, right? So if we make foo 3, it's still a valid foo, right? But if we do something else more evil, let's say we set x to 3, which is totally not valid according to our original contract. It's an integer, not a vector. Now our foo predicate's gonna fail, right? And so the pattern that I used in building libgrimoire is I basically went out and did a whole bunch of these def tags, right? So I have a def tag group that just represents a Maven group, right? And an artifact that has a parent and a name, and the name has to be a string and the parent has to be a group, right? And a version, parents an artifact, strings and names a string, and so on and so forth. And then I can go on down here. These are complicated, so I'm gonna ignore them. I can say namespaced, right? So a predicate testing where the input is either a namespace or has a namespace as a parent. And that's going to be the logical conjunction of whether it is a namespace itself, or you could walk up its parent tree and find a namespace, right? This turns out to work rather nicely because now I can come down here, actually override a bunch of constructors for validation reasons. And I can start doing things like thing to group, where I can say my input must be a thing, right? And it's also got to be artifacted. There's got to be an artifact parent somewhere up the tree that I can pull out. And if it's not an artifact, then we're gonna walk back up the tree until we do get an artifact, and then we're gonna return the artifact, right? So if I give you a thing that's a def, and a def has a namespace for a parent, a namespace is a platform for a parent, a platform is a version, we can walk back up that tree until we get to the Maven artifact and return that. That make sense? And honestly, that's basically all there is to this pattern, right? You have predicates, and you can write your contracts out in terms of predicates rather than types. Your predicates are just functions, so they redefine and reload really elegantly like functions without any type checking break in your workflow. And it's a trade-off between real static validation and getting a better REPL experience in Clojure as it exists right now. But it's one that I found highly worthwhile in building this tool and others, and one that I would encourage you to check out. The last thing I will show off here before I stop yakking is the search operation that's implemented as a pattern match on Guten tag values. So the idea here, ooh, hello, looking at the wrong implementation. DLF method search, there we go. So the idea here is I'm going to match a sequence, right? And I can have, well, F is, okay. This is not as good as an example as I was hoping it was going to be, even though it's quite cute. The idea here is I can write out a description for any entity in the Grimoire data store, right? And independent of what the data store is actually backed by, I want to be able to use the same logical search interface. So I want to be able to take this one implementation and plug it in on top of RethinkDB or the naive file system data store I have, or anything else that I might want to transition to in the future. And I can do that here by saying, I'm going to recur, I have this function recur and filter, right? That's going to do assert, takes a config, a pattern, an element, and some function that I'm going to map over the results. And we're going to do a search recursively for the parent of the pattern, right? So remember I explained that I have this tree data structure where I have entity, I have art platform, so I have Maven, groups and then artifacts and versions into Clojure land platforms, into Clojure land namespaces, into Clojure land devs, right? So here, if I want to find a def with some group ID and some artifact ID and some version, some platform, some name, that's the same as wanting to map a predicate over the names of all the namespaces that match this pattern, right? And so I can recursively pattern match back up by mutually recurring through this function, recur and filter, and then the search function itself. That makes sense? And I can do all this because I'm doing pattern matching both on the results. So I'm only matching on successes. If I have a failure, then I return nil and the thing cascades back up nicely. And if I have invalid data, right, I'm going to get a pattern match failure on the search function itself. So you actually can't put an invalid query into this thing because the pattern matcher guarantees that you'll get a precise exception that says where your query was invalid. That makes sense? So that's kind of the wrap here. Guten tag is very beta. It's something I slapped together in a weekend, conveniently released on April 1st. It's not, in fact, a joke. I found it useful. I will probably go and rewrite Tools Analyzer over the course of the summer using it because Tools Analyzer makes the map type name mistake that I railed against earlier in this talk. But yeah, I think this is handy, so check it out. That's all I got. Comments, complaints, don't come back with your types nonsense.
No, Sam's not here, you're safe.
Yes. All right, thanks guys.
All right, so you want to go next?
Okay, so my name's Nola. If you don't know me, I'm a Rails programmer by day, and Clojure is just super fun. I'm on my next job to be on Clojure. So we're going to talk about Honeysequel. I don't know how you say it. I call it Yes SQL. YesSQL.
Have you heard somebody give a talk on it to say?
YesSQL.
SQL, yes.
I just my head goes YesSQL. And then Korma, which is a little bit different than those two. Honeysequel is used using Clojure to build query strings. There's a couple different ways to do it. One way is to use a map in passive format, or you can use the functions to build it. And it doesn't validate your query at all, so you could do the total gibberish or make a query string, and it would not work. Here's the SQL map. It's just a regular map with the keywords there, and then vectors for the parameters. And you can call SQL format on that, and then get a string with the query, which can be consumed by SQL, the JDBC thingy with the parameter substitution. Using functions, you can do a similar. So that's this is the threading macro, right? If you saw that, this is a talk on Honeysequel from Clojure West by Fumiko, and it's really cool. You can have these in different orders. You don't have to have SQL. Select first. You can be at the bottom, and it'll combine them, and that's pretty cool.
That's because it's making a map in order. It doesn't matter because it's just keys and values.
So it's building a map internally with those functions. Cool. So yes, SQL. You have your query in a text file. I don't know if you would put it in resources, but I thought I would put it there for like a web app. Just put a text file with your query, question mark for parameters. Then you build a def query, passing in a name of the function and the source for the SQL, and then you can use it as a function, recipe by ID number, and that will call it. And I thought that was pretty cool. Korma, which is what I've done the most of these, it's not really like the other ones. I learned this first because I was like, where's active record? Because I'm used to that in Rails. Like, where is your active record like thing? And Korma is like, cool. So it's more like an object relation map, sort of, but not totally. You define entities, which are basically the table definitions. And you can define relationships such as has many and belongs to, but I have not done those last two things yet. Here's what the entity looks like. If your table name is singular, recipe, you don't need to have that in there. But in Rails, we name our tables plural because it's many things, makes sense. But it's not so with this. So if you have your table name not singular, you get to pass it in like that. Primary key ID. I think their default, the ID field is recipe ID or something. So if you don't use that, you got to pass in the primary key and then your list of field names. And that is used. You still use like the SQL keywords, insert, select, delete, update, passing in the name of your entity, and then the parameters. And I found that pretty useful. I made functions for all my database actions, like add recipe, delete recipe, but then it ends up being just like that long in a function. And I was like, wow, maybe I don't need to put it in a function. I don't know. That's you can see then you could switch out your database later, changing between different SQL libraries. Cool. So I kind of decided like why wouldn't we use one or the other. Corma was good because I like my object-oriented database structures. Yes, SQL. I think if I had a DBA who would write SQL for me, I'd be like, here you go. Put me the files, and then I don't have to do any of that because I don't really like doing SQL. As a good Rails developer, we don't want to do SQL. HoneySQL is good if you want to do SQL and Clojure. Maybe if you had to do a lot of combining, getting options from the user, combining into that, then I think HoneySQL would be a good option. And that's it. Any questions?
Try doing any table joins at all?
No. Yes, SQL, you just write it in. With HoneySQL, there are functions for left join, right join, putting in table names. And with Corma, you use has, many, and belongs to.
Right.
And that would get a join for you.
Which one did you like working with the most?
I have used Corma. The other two I've read about. I mean, I've had yes SQL on my list for like 3 months. Chris, you have a question?
No, scratching.
Scratching your head. All right.
So we use Corma, but we use it the way that you showed HoneySQL. So we don't use any of the entity stuff at all. We do but we use it the way HoneySQL works, which you build up your queries. Because underneath, that's how Corma actually works too, a series of maps. So it's interesting to see because I've never actually used the entity stuff in Corma. I use Corma every day.
So you guys look at changing it, like, because
it would be. I mean, we used it because that's what was available. You know,
I think
when it came, it was pretty much the only thing. Back in time. But I recommend that the pattern that HoneySQL uses, that's being able to build up your queries as a map is really super powerful. So that's how we do all of our queries. Like we have base queries, and then I think I was just talking with Dar about this the other day, and then we have things, if we want to do like a range or a limit, like, based on user or something, we have these predicates, and we can just apply those to the map, and it will add in the, all the permission checks or the date checks or something like that, so we can actually build up these queries in a really elegant way. So I guess I'm making the argument for HoneySQL there, but I don't know how well it works. But we do that with Corma there. So.
Is Corma still actively maintained? Or?
Not really.
Not really.
Did you check?
I don't think it's abandoned, but I think it's pretty stable.
Feature complete.
It's not broken.
I submitted a pull request, like last year sometime, and nobody's put into. So we actually have our own fork of Corma, just because there's one particular bug fix that was critical for us, and nobody pulled that in yet. So
Go hang on Twitter like a good American.
Has anybody else? I'm curious. Anybody else have used more than one? Because I've only used the one. Nobody.
I used that one that Sean Corfield had. Well, I don't think
That's just Clojure, just the Clojure JDBC.
Yeah, the JDBC, but he also had just a SQL.
Okay.
Like just build it up with keywords and stuff like that.
Okay. Yeah. What is?
I don't think I gave up on it. Just think of something else.
Yeah, I have a vague notion of what it is. JSQL maybe. Oh well, we'll look it up.
Everybody see that?
Yeah.
You see that one? No? Okay. Okay, so I'm going to talk a little bit about the new CIDR debug feature. This is just a simple factorial function. This is a really contrived example, but I'm going to go through how you might debug this. And imagine that it was a slightly more complicated example. With something like this, I would probably just print line and debug from there. But if you look inside the function, there's only 3 operations going on really. You're assigning some little local parameters, you're checking if they're 0, and then you're recurring with either a decrement or an accumulation. It's just a standard factorial. Okay, so if you're working with atoms like I have up here to you know, decompose this function, then you'll probably end up with some reset statements. So you'll have something like reset in and give it a value, say 5, so that you can do a factorial of 5. And then the next step is you can see this setting the counter equal to n. So reset counter, and you have to remember to deref. And the next step is to set the accumulator. Good so far? Okay, so the next thing it does is it checks if counter is 0. What do we got here? I did not deref. Okay, so since it's not, we recur, and what's the first step in the recur?
Decrement the counter.
Decrement the counter. So reset counter, decrement, and deref counter. So now the counter's 4. Okay, what's the next step? Reset the accumulator. And it's just the multiplication of the accumulator and the counter. Okay. I see a problem so far? If you remember doing factorial, it's always n times n minus 1 times n minus 2 and so forth. We've already dropped our accumulator down to 4. So debugging with atoms is pretty bug prone itself. The reason for this is because I changed the state of the counter with that decrement before I got over to the accumulator step. And so we'll end up with 4 factorial instead of 5 factorial if we keep going with this. So let's reset those.
This is how you debug stuff before you hit this.
Yes, this is the way we debug. Does anybody else use atoms to debug functions? Never?
I sometimes use it to, like, if there's a value deep in a call that I want to save, I'll reset into an atom somewhere and save it out somewhere.
Yeah, and typically it's not something so simple like this. Like, it'll be a big map that you're passing into a function, and you know, it won't be just checking if it's 0. It's going to do some sort of really, you know, sophisticated test. But this is pretty much along the lines of what you end up doing. You end up resetting atoms, and usually what I end up doing though is at the beginning of the function I actually reset and I capture whatever parameters pass in. Because in the functions that I work with, they're big parameters, like huge maps, and I wouldn't want to type those out by hand. And those are also still too big to print lines. So I end up working with atoms a lot whenever I'm debugging functions. So I mean, you get the stateless app that you're working in, and so you add some state to keep track of what's going through there and watching the process play out. Okay, so if we do the accumulator first, I mean, probably in a real app, you'd end up creating another layer so that you could swap out values temporarily. So you have like a temporary accumulator and a temporary counter. But in this case, if we just do the accumulator first, we'll be fine. So that's 5. And we can decrement the counter. That's 4. And then we can check it again. It is false, so we get to recur again. Reset the accumulator. 20. Decrement the counter. It's kind of boring. This is the way it goes. Okay, so that's the right answer. We're still at 1. So we have to decrement again. Where'd it go? Okay, and we're done.
What's your history thing at the bottom?
This is just the messages output, and the reason I have that on there is because later on when I'm working with the debugger, it's actually going to be outputting there, and I could not get my little mini buffer to expand in the GUI version of Emacs very easily, so I've got this out here to demonstrate this. So instead of using atoms, now we can go over and actually test out these functions directly using the debugger. Just to show the same thing, you can see that I just executed factorial 5. got the result of 120 over there. So the way the debugger works for CIDR is you go into the definition of the function that you're going to be debugging, and you have to instrument it. And so there's some Clojure code that's written to do all the instrumentation. You can see that they make a map and they transform the function, they decorate it so that they can step through it and keep track of like line numbers and stuff like that. Also, a big part of it was written in ELISP because it integrates with Emacs to keep track of like tracing and stepping through whatever. But there's a simple function call that does this, and there's also a little command, which is a Emacs key chord or whatever that you press. And so you can see that it's instrumented factorial. And so now, if I execute the factorial 5, it actually steps into it. And so you can see that it moved my cursor up there. So the first thing that looks like an S expression, I guess, is when counter is getting set to the value of n. And you can also see that it's got a little menu that it gives you. So you can use n for next, C for continue, and so forth. So I'm just going to hit n for next. Okay, so now we're checking to see if the counter is 0. It's false. So it's going to decrement the counter, and it can do that because it's not changing the state of the actual counter inside the scope of this function. That's going to accumulate.
Is that moving your cursor?
It is. My cursor is jumping around. I'm just hitting the N key to move between here. So yeah, I'm just following the menu. I'm sorry.
So you can tell which line is with the cursor.
Exactly. Yeah, you're probably used to maybe some other types of debuggers that have like little red circles for breakpoints and maybe like a yellow line to trace around. But I don't know if that'd be really useful in a list because you're nested inside so many parentheses, jumping through S expression.
Maybe the line is displayed in your console thing. And then you go next and it shows the next line.
Yeah, but this is expression by expression, right?
Okay.
So right now it's telling you the value of accumulator is 5, right? Yeah. Because it's right after accumulator. So hit N again, right? Now the value of counter is 4.
Oh, I see.
And right, yeah. Oh, sorry, it's not my talk.
No, I like participation.
It's just exciting, sorry.
So this is doing basically all the stuff that I would normally have to set up some atoms to go through. And so you got to 60, 120, and we're just about done. Get through the last one, and it's over with. That's the final result. And I guess you can see that because it's a little bit unindented, but I always end up hitting N a couple extra times and I'm done, and it's a little frustrating. But so that's just the basic factorial function. This was the example that the author of this new functionality came out with. It's a dummy distribution. It doesn't really mean anything, but you can see that it's just creating a distribution of like whatever value you pass in, going 20 records wide or whatever. So we can instrument this. So I just hit evaluate instead of instrument. So you'll see something like that if you hit the wrong key. Okay, so now it's instrumented. And so if I do this again, I can come up here and so looking at those menu items, we've got some other options on here. I don't have to just hit next. I can actually go in and change the value. So in this case, I'm gonna hit I so that I can inject, and I'm gonna change it to 20. Okay.
You just changed N to 20?
I did.
But just in the partial though, right?
Yep. That's it.
So you changed it for one evaluation of that.
Yes, I did. Yeah, that was it. Okay. So it's just like to go in there and say, oh, I want to fiddle with it at this point and see what it's doing. And don't be too concerned about the fact that it's a partial or whatever. It's just a function that we're playing around with.
Okay, I'm just making sure you can rebind into some.
Yeah, it's not like it changed the value of n. It's just so if you think of how it evals, right? It's like it says give me the value of n, and then it call partial with the value of plus and the value of n.
Okay.
Well, you look up the value of n as 10, and you say no. In this case, I'm looking it up, and I'm going to pretend like it was 20. N never changed, right? Just the value that it evalved to in this particular expression.
Yeah. And this one's not recursive, so it'll be over with quickly. So you can see it moved, started with 20 this time. That's all there is to that. In addition to injecting a value directly, you could put it in an evaluation. So if you have some sort of complicated value that you're working with, it's not necessarily just an integer or something like that. You could actually could paste in an expression and evaluate it.
What does out do? Do you know?
Yeah, it just jumps out of that as expression up to the.
Oh, just up to the. Sorry, up one level or?
I believe so. We can test that. Make sure I'm done.
So like if you've got like 10 args or something deep, it will just pop up.
Looks like it jumped all the way out. It might have to do with like function nesting. Maybe it jumps up to like the next instrumented function. There's some documentation on that.
And was the instrumentation is automatic? You just say, hey, instrument this thing up?
Yeah, you just run the instrumentation command. In Emacs, it's control U, control meta X.
Okay.
How do I do it in Vim?
Does Cider work with Vim?
Sorry. Not exactly.
No. Okay, so
Recognize the error in your ways.
the next example I got when I was reading over the documentation, somebody asked specifically like, okay, this is just instrumenting one function. What if you have multiple functions? So I've created this little ping pong example. In this case, I can instrument ping. And if I come down here, I call it with 5. I can see that the output was up in the top. And actually, I forgot to instrument it. I hit Control E again. I'm so used to hitting that. But you can see that in the Cider REPL, it printed. So let me go up and instrument this properly now. Of course, it's instrumented. And so now it's up in ping, and so it'll do a print line. So you can see ping 5 right up there. And it's going to do this little test. Is it less than 0? No, so it's going to go to Pong. Okay, and I didn't step through Pong. And so the reason for that is because Pong hasn't been instrumented. It's going to step over any functions that you haven't instrumented. So I'll just hit continue and let it finish printing out. And I'll go ahead and instrument Pong to demonstrate. So you can see now it's jumped down to the Pong function. Back and forth, ping pong. It's funny.
You know, if you do out, will it jump out of the palm?
That's what we want to test, yeah. It does.
Nice.
Does that have conditional breakpoints? Or breakpoints at all?
Well, they're all breakpoints, sort of, right?
It's breaking on every S expression this way, yeah. I have not seen anything about that. Good question.
Should use cursor for that.
Yeah, it's just such a big step forward from what I'm used to that I didn't need to do. So for my last example, I'm going to do a little macro. It's just a win macro. Let's execute this first. And so you can just see it says math works. It's just testing that 1 is equal to 1. And so I'll go up and instrument it. We'll call it again. And so you can see the first thing it's doing is it's checking, it sees that there's an if test. And there's the actual test.
So just to be clear, when you instrument the macro, it's instrumenting the code that gets run when the macro is used, or the code or the macro itself when it.
From what I can tell, it's doing the macro itself because what you'll see here in a second is it basically macro expands it as you're stepping through.
Okay. Like it creates a version of the macro that has all this.
Yeah. You can see that it's building the macro up.
Oh, so this is the evaluation of the macro
Yes.
itself, not. Okay.
Yeah, so I believe it instrumented the macro, not the expanded macro, I guess is what you're referring to. Is that right?
So. Okay. Does anybody
around that.
Yeah, no. Does anybody know understand what I'm asking? Or
Yes.
if you don't know the answer, yeah, I don't know how to express it.
Are we debugging compile time, or are we?
Yeah.
Oh,
So
yes, it is compile time. Good question.
So this is the macro running
with the
not,
values that
not
you're passing.
the code that
Yeah,
the
yeah.
macro evaluates.
Yeah, it's not just a plain expand, I guess.
Okay.
It's like actually
Gotcha.
taking values that it's passing in and it's evaluating it. Yeah.
Gotcha. Because I see the expressions over here, so I'm assuming it's the evaluation of the macro,
Yes.
not the code.
Yeah.
That,
It's not just doing like a pure expansion. It's actually evaluating and running.
yeah, but like the if itself, like something that's using the macro,
Yeah.
that's still, okay, gotcha. I think.
I guess the question is, to trigger this step through, were you running the MyWin or were you running the def macro?
So you
You instrumented the def macro.
I instrumented the MyWin, and anytime you call that function afterwards, it actually goes to the instrumented version and steps through it. And
Right.
so,
Okay.
like if I jump back up here just to make like a simpler example, and I do paying 5,
Yeah.
it'll actually jump out of that and step right into it. So it's whenever I called it and evaluated it that
Yeah.
it started stepping through it,
Okay.
which is right there. I just evaluated MyWin.
Right.
Math works.
Okay. And so when you did that, then it went back up into the macro definition and started stepping through the definition.
Could be useful.
Yeah.
What other questions? Pretty good participation on that one.
Can you uninstrument one of these?
I was looking for that earlier today, and I could not find anything to uninstrument
Just
because it got so frustrating. I kept hitting. You know,
Just eval the function again.
Yeah.
Eval the defin again.
Okay, so let's see that.
And create a new one.
So it's evaled, and I can jump out of this. Nope.
Well, that's the polling though.
Yeah.
Yeah, do both of them. That's good.
Thank you. Yes. Good. There's your uninstrument.
Pretty cool.
Cool.
Very nice. Thank you.
Thank you.
All right, so I did something new this past month for the first time. I created a Leiningen plugin. So I'll tell you about my plugin in a minute, but I thought maybe my plugin itself not super interesting to anybody who doesn't have the same use case as me, so I thought I would show how one would create a Leiningen plugin. Turns out to be really simple.
It's a pretty cool use case, though.
Yeah, I'll explain that in just a second. I just want to show. Okay, so everybody, if you've done use Leiningen, there's a new line new. So if I want to create a new plugin type, I'll make a plugin. All good Leiningen plugins start with line dash, and then I'm gonna code for you line calce. Familiar with calce?
Sure.
Somewhat. Okay, good. Excellent. So calce is like hello Austin Clojure, right? So I want to be able to say hello, I want to be able to say line calce is because why wouldn't you want to do that, right? All right. So what gets created here? There are some pretty interesting calce alternatives in the if you do yeah, you've got, and this is not even, there's actually another set of them which are I would not dare to even use. Okay, so what this does is this creates a Leiningen plugin, and notice all a Leiningen plugin is a Clojure project. The namespace should be the name of the command, right? So it should be Leiningen. So if the line jar command would be in Leiningen.jar, right? So our new line calce is going to be Leiningen.calce, and then you have a function here that does. I'll get rid of that too for clarity. Right, so now I can already do, right, and it's going to run that code.
So let's start the JVM and compile it.
Yeah. But so now this is just working because I'm actually in the project, so it's got the code. So I'll show you how to actually install it and use it in a second. But let's actually do this. So I'll make a see if I've got time to do. Wrong one. I'll get my cow here. Okay, so let's just add some quick code here and line, and then I'll line, something like that, maybe. There we go. So not quite as impressive as the real calce, but for now that will work for us. Okay. So how do we use it? So there we go. We've got this. I can run it, but I can't come over to another project, right? If I come over and make another random project. There we go. And then, if I do line calce, that's not going to work, right? Because I haven't included that. I haven't done anything. Let's just see it fail real quick. Oh, okay. This is because being a good demoer, I actually did this already, and I created a calce here. So what I really want is to have my line calce in here instead of calce, right? So what I'll come over here, so I was just going to show that if I want to do this, I need to give it a good version number, and then I'm going to line install. Line install puts it in, creates a jar for it, puts it in your local Maven repository. Oh, sorry, just one second. It's trying to resolve that, which doesn't exist yet.
What is that bang hash thing? I mean the underscore hash thing.
It comments up the next.
Oh yes, that's a Clojure. So all of these things all of these are things that I've commented out so that maybe I want to use them sometimes, or I don't want them to interfere with something. So that's just I could have easily done that, but somehow I've gotten into I use that as a.
Interestingly, the guy that did the large scale Clojure talk at Clojure West said that particular comment method was the least error prone, and I had some issues with all the other ones.
Oh, yeah.
So like the comment macro.
Line based.
Yeah, it's expression based. So if it goes like this, it's still going to, right? It still works.
And the comment macro returns nil,
It
which
does.
burns some people sometimes.
Yeah. Oh, right. So if you do like comment, yeah.
Well, you do comment when, then you have trouble, right?
Comment.
Or when and then a comment.
Oh yeah.
Somebody needs to make a win comment macro to get rid of this problem.
when comment. Well, when comment still has to return something, right?
Does it?
Everything has to return something. Run it through your debugger. You'll see the nil, right? Okay. So anyway, so I've installed it locally. So now I can actually use line calce. And so here in my another project, I can line calce. Hello, Austin Clojure. You see my other version actually had little brackets in here, but I didn't code that this time around. There we go. So how would you use this? Like line do, so jar calce, jar's done. Something like that. I don't know. I'm just trying to invent a use case for my thing. So you could put that in an alias, right? So in your project, right? So if you were to,
Wait, how'd you get the formatting this time?
Uh,
You got two versions running around.
oh, okay. Yeah. Sorry. I need to do.
But
Yeah, you're right. Because it's using that's using the real one. So it would actually be.
because you didn't do. Oh.
Yeah. So it's. I guess it would.
it's 'cause- yeah.
Oh, wait.
The semicolon goes to bash.
Yeah. Stupid. Is that it?
The semicolon ends his line until he puts it in quotes.
Okay. So the way this actually. Okay.
There's got to be a different way to do line.
Yeah.
I don't know what it is.
Spell line again. Second one.
So here, I'll show you what the do looks like because I apparently
Yeah, I can't remember how to do it.
I have, comma separate.
No, it's, hold up. So like for instance, this is from my work project. So we have a build command that's a clean Clojure script build once. Oh, it is commas. Okay. Whoever said comma was right.
I run that all the time. Line, do, clean, face.
Okay. And it's
Pulling you out for
Yeah.
cheating
no, that's good.
What if you want to have a comma inside of your calc?
Then you send that email to the guy who wrote Leiningen and ask him how to do it. No, I think it's only the comma has to be the end of a word, right? Like so if I say calc jar comma s done like that, if it's just a comma there, it shouldn't try to do s. If my minimal understanding of how Leiningen do works, yeah, right. But if I did jars comma done, that should try to call a done task, and I expect it will complain that it says that there is no done task.
Yeah.
Do you mean do? So, and clearly my inferior calc here, not the real calc. Okay, so that's really all there is to creating a Leiningen project. I could actually push this up to Clojures now. I'd have to sign it, but I could push it up to Clojures, and then you could all line calc. So what was my plugin? So I had a use case. So if you've used line jar, right? Line jar will create a jar file with all of your Clojure files, all your resources. It's what you would push up to Clojures or something if you were deploying your code, right? There's also a task called uberjar, and uberjar creates a jar that has all of your code as well as all of the code of all of your dependencies, right? It builds up all of these jars, right? And when you've got a really massive project like this, hold up. So you see we've got quite a few dependencies in here, right? Well, so you've got a lot of dependencies. The number of files can get really, really large, right? And it can get especially large with Clojure because everything you do creates all of these anonymous, every time you do a anonymous function, that's a new class. Everything in Clojure goes down to a Java class, right? So big deal, your jar gets really big. Well, it turns out that there's a limit to jar files as of Java 7, which is this is 16-bit counter, so you can have 65,535 files in a jar, right? So with Clojure plus a project that's way too big and needs to be split up into multiple projects, and like a ton of dependencies because of that, right? You can, it is possible to get larger than 65,535 jars. I mean, 65,535 classes in your jar. This is fixed in Java 8, so, but at work we couldn't move to Java 8 just yet. We were waiting on ops and some other things. So I had to come up with another mechanism. So I created a new thing called a meta jar. So the meta jar is the same thing it's basically like, and this is just an artifact of how we want to work, or the way that people tell me I have to work, want it to work. And then that is, there has to be one jar with a main in it that we can call out to, right? Just like an Uber jar has a main, right? And we can't set the class path. We just have to be able to say java-jar, our.jar, and it has to run, right? So how do we do this? Well, it turns out that Java jar files can have a manifest. Manifests can list dependencies. So if I have a main jar here that's just a regular Leiningen jar, but it has a manifest, and then I copy all of my files into lib. So I have lib.x.jar, lib.y.jar, right? And the manifest lists all of those sub files. I can still java-jar, app.jar, right? And I don't have any external class path. The jar maintains its list of dependencies, right? I can run. So I created a Leiningen plugin to do that. It basically does the jar, inserts the manifest, and then it copies all the files into the lib directory. And then we've got something that's to the outside world is equivalent to our Uber jar, but yet is not limited to 65,535 classes because they're all split up in their original jars. So what does this code look like? Turns out to be fairly straightforward. Here's my Leiningen meta jar. So it's line meta jar. And this is it.
I create the jar. I copy a bunch of files over, the lib directories over, and then there's another piece in here that gives it the set of classes to use in the manifest. I won't walk through the code because it's not super interesting how it works necessarily. I had to do a lot to understand how Leiningen, trying to figure out what Leiningen is doing when you want it to do something that's different than what it wants to do. Turns out to be very tricky. So even though this is just a couple lines of code and a couple things over here, I added a new profile, a metajar profile, right? And this is where I get the manifest, the manifest class path, right? Even though it's just a couple things, it took me, it actually took me like several days to get this all worked out, mainly struggling to figure out what Leiningen was doing and not knowing how to debug Leiningen. So I think I need to find a Leiningen guru. Maybe I have to go down to Houston and talk to Nelson or something. Find somebody who understands how to actually dev Leiningen, because I still have no clue. It was quite. I had to throw all of my debugging tricks, because you think you've got a plugin. It's like, well, if I can get it up in a REPL, but I already get, this is inside line, outside of everything else, and trying to find ways to test this. I threw Robert Hooke at it. I threw just about everything I could. I became quite adept at finding ways to figure out what was going on. So, anyways, that's not super interesting. But that's how you create a Leiningen plugin. So if you have some task you want to do, I mean, it's really quite simple to do. I was, I didn't expect it to be all that hard, but I was really surprised how easy, except for actually wrangling some of the internals of Leiningen to get it to do the right thing for my jar, right? It was not too bad. So there we go. Cool. All right. I think that wraps us up. I did want to take some time. We usually do this at the beginning. Does anybody have any Clojure questions to raise to the group? Something you've been trying to work on? Something you are struggling with? Anybody have anything this month? We're all dead. We're excellent.
You talked about association to change the value of the key in the hash. Return the hash with a new value for one of the keys, because that's
okay.
I've tried it, but I can't.
From last one. What we're talking about last one.
Let's pull up a REPL and see what we can figure out here. Okay, so you're saying we have a map like this, right? Is that what we're associating? Okay, so let's
create another map as one of those.
Okay, so I'll call this M for map, and so one of these is like this, right? Is that?
Yeah.
So okay, so what do we want to associate? What key do we want to change?
Just change the value of Y.
Okay, so anyone want to tell me what to type for association?
Vector.
M. Is it M and then the vector?
Can't remember.
Alright. Map, then keys, then values.
C.
So C, then Y.
And we'll set it to hello, because we should always change numbers to strings to make read happy, because it's clearly well typed, right? Like that?
I say the pass, even if you have one value, it's supposed to be a vector.
So if we were just going to change, so if we wanted to replace C in, sorry, let me not delete that. So if you just wanted to replace the whole C by hello, it would be the same thing. You would still have to pass it in the vector.
Alright, that's a weird thing that got me stripped out, because I'm like, I just want the key in the
Yeah.
In that case, you wouldn't really need to use association.
Well, that's true. Yeah, so we could just use assoc in that case. So assoc sorry, I am a bad typing person.
That's
Did you say you just need?
true, but in my experience, that's the most helpful with an update in.
Oh yeah, that's what I was trying to do. I was trying to do
Because there's no just update.
Right. So okay. So let's do that. So we'll change Y, but instead of doing that, we'll just bump it by 1, right?
Mm-hmm.
Oh, sorry, not association. We want update in. Update in.
Yep.
like that, right? So,
Oh, there is an update in Clojure 1.7, right?
Is there? Oh, I don't know, there might be. I haven't looked at it. That'd be cool. It always kind of annoyed me.
does that make sense? Yeah, so I love updating Association. I use these all the time. And by the way, for since I did see something, so we had you were using atoms. So def in atom 1. Okay, so you're dereferencing it, right? So what you were doing is you were doing update n plus at n 1, something like, whoop, did I type that wrong?
Doing a reset, yeah.
Yeah, reset, sorry, okay. Right, okay, so you can also do,
Swap.
is it swap?
Yeah.
So if you're just trying to use the current value, because otherwise you have to dereference on the right hand side. I got confused by your, by what you were doing just because.
always just use reset for some reason. I don't
Yeah.
know.
So I just thought, in case anybody else was looking at that.
Pretty much.
It might be difficult to anybody.
Yeah, I don't know. I just since that was there. All right. So do you have anything else we wanted to look at about that, or just see how that worked? Okay. Yeah. Any other Clojure questions to throw at the group? Let the collective intelligence of our spent minds flail at your problems. All right. Well, I guess that makes a full meeting. We can hang out for a bit downstairs, and we usually go down to the bar area. So come hang out with us and not write code. If anybody wants to speak next month, or do a short, long, or any sort of talk, let me know, or let Sam know by email.